Hello everyone, this is DSA Zindabad and today we are going to discuss the daily challenge of Leetcode, which is divide arrays into arrays with maximum difference. Let's jump into the problem statement. You are given an integer array nums of size n and a positive integer k. Divide the array into one or more arrays of size 3 satisfying the following conditions. Each element of nums should be exactly in one array. The difference between any two elements in one array is less than or equal to k. Return a 2D array containing all the arrays if it is possible to satisfy the condition. If it is not possible, that means if it is impossible to satisfy the condition, return an empty array. And if there are multiple answers, then you have to return any. Okay. So basically, after reading this problem statement, I understand that I will be given a nums vector, right? Something like 1, 3, 4, 8, 7, 9, 3, 5, 1 as an input, and I'll also have k, right? For this test case, k is 2. Okay. So what I need to do is I need to divide whole of this nums array, right? Such that I can have one or more arrays. The number of array can vary, but the size of each array should be 3. That means it should have 3 elements in it. And the number can vary according to. Okay. So the number can vary accordingly and the size of each array should be 3. Now, when we talk about dividing this nums vector into this part, these are two conditions that we need to follow, right? That means that each element should occur exactly once per array and the difference between any two elements in one array is less than or equal to k. So basically, this second condition is very important. It is saying that as you know, I'll be having 3 different elements in my subarrays that I'll be creating, right? I'll not directly say them as subarrays because we can put them in any order that we want, okay? This same ordering is not required. So the arrays that we'll be forming, the smaller arrays is the better word that I'll use, that we'll be following, in that the difference between any two elements in one array should be lesser than or equal to k. So for example, I had something like 1, 3, 4. I mean, I have not applied anything. I'm just giving you an example, right? So herein, if you subtract 4 minus 1, you get a 3. But the value of k was 2. We want the result after subtraction that it should be less than or equal to k, right? But here it is greater than k. So this cannot form a smaller array of size 3. So I cannot form for this. Let's see something else, right? Can I work with something like if I choose just 1, 1 and 3. So if I have 1, 1 and 3, right, I'm randomly picking them. Okay, just to understand what approach we'll be building for. So here, if I subtract 3 minus 1, I get a 2. And it is satisfying the condition because we have an equal to. So it says, okay, now figure out for this one. 3 minus 1 is again 2. So it is also satisfying the condition. Hence, this can be considered as a smaller array of size 3. Okay, I hope the problem is clear to you. Now let's talk about the approach. See, when we say that we need to find the smaller arrays of size 3 from the given nums array, what we mean is that I want somehow that I see here what is happening is, if you could see, if we had something like supposedly in this there was a 2 also, right? In place of this one we had a 2 also, right? So if you see here that if I would have picked, when I was randomly picking different combinations, if I would have picked a combination like this, and then if I would have start subtracting 3 minus 1, that's 2, it satisfies the condition because it is not greater than the value of k, that is 2. If you have something like 3 minus 2, that is 1. It is again not greater than k, satisfied. So if you see, if somehow I could figure out for all of these, the minimum and the maximum. And see, when you say that, if you know the minimum and the maximum, right, you do not have to worry about the center part. And how can I get the minimum and maximum and always make sure that my maximum will be greater than my minimum? It is possible only when you sort the array. So if I sort the array, right, in the beginning only, I'll sort the array, then I'll try forming these smaller arrays of size 3. I will know the minimum, I will know the maximum, right? So because what happens is when you sort the array, you'll get in ascending order, right? The array will be of ascending order. So you can quickly scan the 3 indexes, okay? And then you can figure out using maximum and minimum, is it satisfying the k condition or not? If it is not, in that case, you can return an empty vector. But if it is, then you can consider that yes, this vector is also giving me an answer. So I'll push it into my final answer. I hope you understood how I have developed this approach. So let's write the steps for this approach. Basically, my first step, as I said, will always be to sort the given array, right? Because once we sort the array, it will be easier for us to have the minimum and maximum, right? Then what we can do is we can start from the beginning and we should check for the 3 consecutive numbers. Okay. And as we've sorted the array, so we know anything that is on the right is meant to be, if this is x and this is y, then x is meant to be greater than y because we have sorted the array. Or as it can have duplicate also, so it is greater than or equal to what is y, right? So in the second step, we'll check for the 3 consecutive numbers, right? And we'll figure out that here we'll have 2 conditions. The first one is after we've checked for 3 consecutive numbers, we got k greater than 0, right? In that case, what I'll simply say, I'll say you have to return an empty vector. But if k is less than or equal to, I'm sorry, the subtracted value, let us assume that's x, right? It is it is greater than k. So we have to return the empty vector. If x is less than equal to k, then you can return the 3 consecutive numbers. Okay. Now, how are we going to do this is, as I told you, rather than, see, when you will be having these 3, rather than checking for both of these values with the third one, it's very easy. You can just take the maximum and the minimum. This will already satisfy because as 2 is greater than mini, but it is less than the maxi. So it will always fall in the range if the first one is being satisfied. So I can simply work with the I minus 2 and the I index, right? And I can figure out these conditions. Then once I have got it, right? So I'll return the answer. So these are my steps that I'll be following. I hope it makes sense to you all. Let's quickly code this up, then we'll have a dry run and understand how everything is working and what is the time and space complexity. Okay, so this is the code. Okay, so this is the question. Now, as we know that we need to return a 2D vector, so let's create one initially, right? I'll be naming it as something. You can name it anything. I'll name it as answer, right? Now, what was the step 1? Step 1 is to sort the given array. Okay. So we have nums. We can use the STL function, right? Which is sort, and we'll give it nums dot begin and nums dot end. So by default, if you use this, it will sort the array in ascending order. right? If you want it in descending order, you can put a greater in here, but ascending order works fine for us. Now, after sorting the array, the step 2 was to check for the 3 consecutive places. Okay. So what happens now is I'll run a loop, right? And see, you'll always run this loop from the second index. Why is it? It is because I want that I will be considering, because we know that we'll be having the smaller array of size 3, right? So if, let us assume after sorting, in the first only we are getting the smaller array which can be added into the answer. So for the comparison, we need to begin it from the second array, second index itself, and the I will be incremented by 3 each time. Why is that? It will be crystal clear to you when we'll have a dry run. Just stay with me for a while. Now, after this, what I'll do is I'll simply, as I told you, I'll have the difference between nums of I and nums of I minus 2. I hope this line is making a lot more clarity, because if I was standing on my second index, right? Just suppose that this is a sorted array here in the example. So if I was standing on the second index, that was 4, if this is sorted, right? So just consider 1, 3, 4. Right now, do not consider the other part of the array. Just consider that the array has the elements 1, 3, 4, right? If the array has elements 1, 3, 4, then in that case, if you're standing on the I index, so I minus 2 will be 0 index. And the I index will be representing the maximum, and the I minus 2 will be representing the minimum, as discussed, right? So we'll say if it is greater than k, that means it is not satisfying the second condition that it should. So you have to return an empty array in this case, right? But if it is, in that case, you simply push it into my 2D vector that I'll be maintaining. And herein you can simply write nums I minus 2, comma, nums I minus 1, comma, nums I, right? And then eventually you can return the answer. I think we're good to go. Let's quickly run it and then submit it. It's running fine. Let's submit it. Yes, great. So now let's discuss its time and space complexity. But before that, we'll have a quick dry run for different examples to understand how this code is running. Okay, so this was the code that we were working upon, right? So let's quickly have a dry run, and I'll be considering the same example that has 1, 3, 4, 8, 7, 9, 3, 5, 1 as the array elements and k is equals to 2, right? So here, the first step after we've initialized this answer, right? We are initializing it here, right? It's a 2D vector. So when you come here, you need to sort the array. So this is the nums array. You'll quickly sort it using the STL function. So you'll have something like 1, 1, 3, 3, 4, 5, 7, 8, and 9. This is the sorted array that you have now. Okay. So now my for loop starts running. My I is initially 2, right? And I'll check if nums of I, that means here on the second index, we have a 3. If 3 minus nums of I minus 2, so I minus 2 will be 0. So on the 0th index, we have 1. So if you subtract it, you get 2. Now you see that 2 is not greater than k, because k was also 2. So you'll not go in the if condition. You'll come here and you'll push that value. Once you push it, your array will have the answer array will have 1, 1, 3 as one of the elements in it, right? So now once you've completed this for loop, I is incremented by plus 3. So I initially was 2, now it will become 5. So your I is here now. Once your I is here, your I minus 2 becomes 3, right? So now if you subtract 5 minus 3, 5 depicting the maximum, 3 depicting the minimum, you can see that you get a value 2. Again, this value is not greater than k, it is equal to k. So it is not satisfying the if condition. You will simply push back this combination also of size 3, that is 3, 4 and 5. Okay. After that, the I gets incremented by 3 again and it becomes 8. So you are standing here now. I minus 2 makes it 6. So if you have the subtraction of the elements present on the 8th and the 6th index, you get a 2, and that is again equal to k, not greater than it. So it is again a valid smaller size 3 array. So you will add this also in the answer, that is 7, 8, 9. And this should be your final answer. Okay. But let's also take another case for you to understand. If the given array, even after sorting, does not satisfy, so what happens, right? So I'll quickly copy paste this code. Yes, let's use this. Now let's take another test case, right? That was the first test case. This is the second test case. Now we have elements like 1, 3, 3, 2, 7, 3, and the value of k is 3. So we've created the answer vector, right? So what happens now is, first we'll sort it. We'll have 1, 2, 3, 3, 3, and 7. So we get something like this. Your I is on the second index, right? So your I is here. I minus 2 makes it 0. So you will subtract whatever is present on the second and the 0th index. That is 3 minus 1. That is 2. As you can see that 3 minus 1 is 2 and 2 is less than 3. So you'll just add the values here, right? Because we are getting the answer, right? So here you can, you'll just put 1, 2 and 3. So after that, your I gets incremented by 3. So it comes here. So I is on the 5th index, I minus 2 is on the 3rd index. You will subtract the value at the 5th index from the 3rd, right? So when you subtract these, 7 minus 3, it is 4. Now this if condition is being satisfied, so you will return this. And then eventually, as you've got 1 empty, that means you were not able to satisfy this, right? So final result will be the empty braces only. That means a 2D vector that's empty. Okay, I hope it was clear. Now let's quickly discuss the time and space complexity for this code. So here, if you see, we are using the sorting STL function that takes O of n log n time complexity. I'll be adding a GFG link for you to know why does the sort STL function take this time complexity. You can always go through it. If you look at this for loop, see, we are jumping by a lot of indexes, so it's not exactly O of n, right? It is something less than O of n, right? And we have not utilized any extra space. If you look at this, this is not an extra space. This is what we needed to answer, right? So the space complexity is O of 1. The time complexity is O of n log n. Thank you so much for viewing the video. If there is any doubt, please feel free to reach out. Thank you. Please like, share, and subscribe.